Welcome back, folks. In today's class, I'll be talking about in detail about the standard deviation, sorry, and also how we use the standard deviation to get the desired results. So we will be talking about one standard deviation, and second thing we'll be talking about is empirical rule. Empirical rule. Okay, so what is empirical rule? First of all, in empirical rule, we have this bell-shaped curve. Now, what is the bell-shaped curve, first of all? Now, if you can recall during the COVID time, what happened that the virus cases were going up, 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 and then everyone was talking about the bending of the curve, and then they slowly came down. So that's what happened. So this is a bell-shaped curve. Now, another example, if you see online, when let's say you wanted to go to Walmart, and if you search on Google Walmart what time it is busy and what time it's free, so you will always say during a certain time there are peak hours, and then it dies down also. So it will also follow the bell-shaped curve. So majority of the things in this world follow a bell-shaped curve. Now, another example I can take here is if I wanted to find the average height of a Canadian man, then it will also follow a bell-shaped curve. Now, let's say I started doing a survey, and I wanted to find out the average height of a Canadian man. So I conducted a small sample from Calgary, maybe 200 people from Calgary, or men from Calgary, and then 200 men from Edmonton. And so let me write Calgary, Edmonton, 200 from Toronto, 200 from the other parts of the city. So I collected certain sample of maybe 1,000 people, and then for these 1,000 people, I wanted to find out, because the objective is to find out the average height of a Canadian man. So what I'll do is from this 1,000 data points, I'll take the average, and that average came out to be, let's say, 175 centimeters. So I'm going to say average height of a Canadian man is 175 centimeter. Now, that was one part of my study. Now I wanted to do the study a little bit more advanced. So what I'm going to do here is I'm going to start finding out the standard deviation for this one. So standard deviation, I have 1,000 data points. I've already taught you how to calculate the standard deviation. You can, if it is a raw data, you're just gonna need a formula and apply the formula, and then you're gonna get, let's say, standard deviation of 3 centimeter. This was 175 mean value, and the standard deviation came out to be the 3 centimeter. And in the empirical rule, or especially when the data is large enough, so that data always follows, or majority of the time it follows the normal distribution graph. So normal distribution graph means empirical rule. So it will follow something like this. It will go up and then will go down. So that's how it's gonna follow. And the right in the middle, you will find the mean line. So the middle 175 centimeter, this is the average height. So when I say the average height of a Canadian man is 175 centimeter, it means, let me just quickly say, is it recording or not? Yes, it is recording. So when I say the average height of a Canadian man is 175 centimeter, it means the 50% of the data uh, is less than 175 centimeter, and 50% of the data points are more than 175 centimeter. So that is the mean value, mean mean average height, that will be represented here. So now, as I said, it has been seen, if the data is, especially when the data is greater than equal to 30, n value is greater than equal to 30, it follows the normal distribution graph or a bell-shaped graph, or you can also put it under the, call it as a, it follows the empirical rule. Now, under the empirical rule, we figured out that 50% of the data is on this side, 50% of the data points out of 1,000 data points which we collected is on the right-hand side of the mean line. Now, uh, the standard deviation which we calculated was 3. Standard deviation tells us how the data is distributed, how much variation in the data is there. So for example, if I move the day from one standard deviation to the left from the mean line and one standard deviation to the right, and if the data follows the normal distribution, remember this thing, data must follow the normal distribution. For whatever I'm about to say, for that, the condition is data must follow the normal distribution. So now, within one standard deviation to the left and the right, there will be 68% of the data will lie between one standard deviation to the left or and to the right of the mean line. So what does that mean? So this was the mean line. Let me just redraw it, the mean line with a different color. So this was the mean line, and we went 3 centimeter to the left and we went 3 centimeter to the right, which means this point becomes 172 centimeter. This point becomes 178 centimeter. So from 172 centimeter to 178 centimeter, the middle 68% of the data will lie between 172 to 178. So for example, so you started collecting the height. So lowest was 150, then 151, then maybe 155, 107, 160, 161, 166, so on and so forth. So, and you collected these data points. The middle 68% of the data, middle 68%, I'm again repeating my words, middle 68% of the data will lie between 172 to 178. How did I figure out these values, 172 and 178? I was able to figure out by moving one standard deviation to the left and one standard deviation to the right. Now, if I move two standard deviation to the left, so this was one, and then add one more to it. So total two standard deviation to the left and two standard deviation to the right. That will cover middle 95% of the data. That will cover middle 95% of the data. So this is middle 95% of the data. And the lower limit for the data will be, again, you will subtract 3 from 172 because you are moving to the left. So this will become 169, and you're moving to the right, this will become 181. So middle 95% of the data will lie between 169 centimeter to 100 and 181 centimeter from the 1,000 data points which we collected. 1,000 data points, 95% of that will be, the lower limit of the 95% of the data will be 169 centimeter, and the highest limit of the middle 95% of the data points will be 181 centimeter. All right. So that's what it means. And if I move one more standard deviation, you only go maximum 3 standard deviations from the mean line. So this was the mean line here. So if you go 3 standard deviation to the left and 3 standard deviation to the right, then you will cover the middle 99.7% of the data. This is 99.7% of the data will be covered within 3 standard deviations, and that is in accordance with the empirical rule. So if any graph which is following the normal distribution, uh, then it will follow these rules. So middle 99.7% of the data will lie within 3 standard deviation, middle 95% of the data lie between 2 standard deviation, and middle 68% of the data will lie within 1 standard deviation. So how does this data helps us? So for example, now again, I'm going to redraw everything so that it doesn't create any hodgepodge. So, going back to the example, this was 175 centimeter, and now I've moved 1 standard deviation to the left and 1 standard deviation to the right. So this was 172 centimeter came out, and down here it was 178 centimeter. So if this is middle is 50% of the data, so 50% of the data is on the left hand side. So this is the middle 50% of the data. This is the 50% of the data to the right hand side of the 1,000 data points we collected. If there were 2,000 data points, so all those, there will be, these will be 2000 data points here. Okay, so I'm converting everything in percentage. So middle 50% means, so 50% of the data points will be above this. Above means 175 centimeter, or you can say uh, if you are 175 centimeter height, this is a random thing which I'm doing right now. I don't know what exact values are there, so I'm just taking and making an example out of my mind. So it means 50% of people are shorter than your height. Okay, and 50% people are taller than your height. But the moment you go to 178 centimeter, then if I wanted to find out how many people, how many Canadian men, according to the sample you collected, how many Canadian men are taller than you. So then you can say that uh, approximately, let's say this is the middle 68%, we said middle 68%. So this is 50. So if I were to do the math, then what you're gonna say, this value will come across how much? Oops, this value will be how much here? This will be, you middle 68 means 34% on this side and 34% on this side. Okay, and so this will be 16% from the starting point. If this is 0 and the whole data is from 0 to 100, here goes from 0 to 100, here it is 99.99%, but we're gonna put it as 100% to make our work easy. Whoops, I don't know what is causing all this, so let me write it. So this is 0% and this is 100% here, 100%. So this is 50. So you go 34 points below, means on the backward direction from 50. This will become 16. From here to here, this is 16 on this. And from here to here, this will become what? This will become 84, because 50 plus this is 34 on the right hand side, this was 34 on the left hand side. So this will become 84 and this will become remaining 16. So it's like 16% here, 16% plus 34, which reaches to 50, then plus 34, which reaches to 84, and then plus 16, that's going to give you 100%. So this 34 plus this 34 plus 34 becomes the middle 68% data. So hopefully you were able to understand now how this is helping us. So if anyone's height is 178 centimeter, he can say that 16% of Canadian men are still taller than him, or he can say that 85%, 84% of Canadian men are shorter than him. So this helps us to make the prediction. That's how the empirical rule is used. So hopefully you understand now where the empirical rule helps us in figuring out the data. All right, now let's look into the question based on whatever we've learned so far. So before I jump into the question, the formula to calculate the values is x minus uh, k times s is equal to, or no, this is mean minus k times s is equal to x, and mean plus k times s is equal to x. This is lower limit and this is upper limit. So lower, what is the difference between lower limit and upper limit? If you are moving, if you are on the left hand side of the mean value, then you will use this one because you are subtracting from the mean. If you are on the higher side of the mean, then you will use this one because you are moving, you are going for the bigger value than the mean value. So for example, here, taking back the previous example, so standard deviation was how much when we were talking about the height? Standard deviation was 3 and mean value was how much? 175 centimeter. I wanted to find what is the lower limit on the both sides, let's say, on the both sides of the mean value. So if I'm going the lower limit, then mean is 175 minus k is how many standard deviations you are moving. K means number of standard deviation. Remember this thing, number of standard deviation. Okay, so 1 times standard deviation value is 3, which is equal to x. So this will come out to be 172 centimeter. And if you are moving to the right, which is higher value, 175 plus 1 times 3, this is 178 centimeters. So for one standard deviation to the left, lower limit is 172, 1 centimeter to the right, it is 178. Same way, if you go to standard deviation, you will multiply 2 times amount of standard deviation is 3, which is equal to 169, and you will do the same thing for the other side also, which will give you 181 centimeter. So hopefully you were able to understand how to use this formula. Again, one more time, K is the number of standard deviation, S means the amount of standard deviation. Amount, it can be S or sigma depending upon the question. S represents the sample standard deviation, sigma represents the population standard deviation. So hopefully you understand the basics of the standard deviation now and the empirical rule. So standard deviation, one more time, helps us in understanding how dispersed the data is. All right, about the mean value. Now, let's look into this question. A normally distributed sample data has the mean of 25 and the standard deviation of 3. Approximately what percent of the data will fall between 22 and 28? It follows the normal distribution. It says normal distribution. So whenever there is normal distribution, we can apply the empirical rule. What is empirical rule? The formula which I wrote down, that middle 68% of the data will lie within one standard deviation, and 95% within two standard deviation, 99.7% within three standard deviation. And then because of that, you will be able to figure out the different values. So let's look into this question. So between 22 and 28. So X value is 22. I'm doing it with pen, but you try and do it on Excel by writing the same thing here. So upper limit is, this is X lower limit, and X upper limit is equal to 28. Okay, so first of all, it is normally distributed and the mean of 25, mean value is 25. So I will use the formula to calculate the amount of standard deviation, number of standard deviation. So 22 is equal to mean minus X times K times, shall I write K times, oops, standard deviation, which is 3. So mean value is 25. This is 22 minus K times 3. And then this is going to go on the other side. 22 minus 25 is 22 minus 25 equal to minus K times 3, which is minus 3 equal to K times 3, dividing both sides by 3. So K value comes out to be 1. So this value 22 is one standard deviation to the left, and we will look at 28 now. So 28 equal to 25 plus K times 3. Again, you do the same process. This will become 3 equal to K times 3, K times, oops, K times 3, and dividing both sides by 3. So you're going to get K value as 1. So one standard deviation to the left and one standard deviation to the right. So if you are moving one standard deviation to the left and one standard deviation to the right, that will cover middle 68% of the data. So what percent of the data falls between these two? 68% of the data will fall between these two values. Same way, I will encourage you guys to do these ones also. Exactly same way, this one will come out to be 95% of the data, and this will come out to be 99.7% of the data. So hopefully you were able to understand that question. Now let's look into another question on this topic. So a cocoa confectioneries manufactures chocolate energy bar. The weight of the bar are approximately bell shape, and mean value is 50. Standard deviation is given, and the weight, the bar that weigh less than 49.4 grams or more than this are considered non-standard and are removed. Okay, approximately what percent of the bars will be removed from the batches. So the lower limit is given to me 49.4, upper limit is given to me 50.9, and mean value given to me is 50 grams, and the standard deviation is given to me, which is 0.3. All right, so let's start doing this one. So mean value or lower limit equal to mean minus k times standard deviation. So we will write down this value. Mean value is given to me, that is 50 minus k times standard deviation is 0.3. Lower limit is 49.4, and let's say if I move it on the other side, this is going to become 0.6 equal to minus k times 0.3, and then dividing both sides by 0.3, and that's gonna give me 2. K value is 2 standard deviation to the left, and same thing if I do to the right, this is 50.9. So 50.9 equal to k times, or mean is 50 plus k times standard deviation, which is 0.3. And if I were to do the math on this one, this will be 0.9 equal to k times 0.3, dividing both sides by 0.3. This will come out to be k value as 3 standard deviation. So let's look into this question carefully now. On the left hand side, it is 2 standard deviations. 2 standard deviations. Okay, 1, 2 on the left hand side, 2 standard deviation. On the right hand side, it is 3 standard deviation, 1, 2 and 3 standard deviation. This is 50.9 and this is 49.4. So all that data which is in this section and in this section, those are waste. We have to calculate these sections now. Okay, so how are we going to calculate this? So if this was the 50%, this is 0, this is 50, and this is 100% data here. Okay, this is middle 68%, we said that. So this will be from 0 to here, this will be 16% of the data, and this will become, this is then 50, then becomes 84, and then becomes 16, that is 100. So same way, if I 95% of the data, so means 40, middle 95% means 47.5 on the left hand side, 47.5 on the right hand side. So if you subtract 47 on the left hand side from 50, 50% minus 47.5%, because you are going backwards from 50 to this left hand side, that will give you 2.5%. So 2.5, this is 2.5% of the data. Now the and then on the right hand side it will be 2.5%, but on the right hand side we have to calculate for 3 standard deviation. So what is the standards for the 3 standard deviation? If there are 3 standard deviation, this will be 99.7% of the data. So middle 99.7. So 99.99.7, it will become how much? This will, if I divide this, let me do this on my calculator, and that will be, whoopsie, where is calculator? Here. So 99.7 divided by 2, 49.85% will go on the left hand side from the middle, 49.85 to the right hand side of the middle. So this value means 0.15%. So spare is 0.15 on the right hand side, spare is 0.15 on the left hand side. So this section which is spare, it is 0.15. 0.15% of the total area. So 2.5% plus 0.15, 0.15, So that will come out to be total 2.65% of the area. 2.65%, oops, of the chocolates which will go as non-satisfactory weight. So anything which has a weight less than 49.4 grams and above 50.9 grams, those are non-satisfactory. So less than 49.4 are 2.5%, and more than 50.9 are 0.15%. So you will add those two, that will give you 2.65% of the chocolates which gonna go as waste. So hopefully you were able to understand this. uh, in the next class, I'll talk about Chebyshev theorem. Till then, goodbye.